Okay, class. Um, this is the last segment of the end of the section exercise problems in section 4. Okay, so number 51 tells us that g of x equals 1 minus x raised to the power um, 3. You could also write this as negative x plus 1 raised to the power cubed. Okay, so in this case, again, you're looking at the parentheses, and this tells you and I that there's a few things going on here. Within this parentheses, we have a horizontal shift. Okay. Okay, and then which we have right here. And then we also going to have a reflection about the y-axis. Okay, so this is the basic. Um, this is the basic graph, which is x to the cubed, right? Now it tells you and I that we have a horizontal shift. So if I make x to be 1, right, that will just typically, this whole expression right here goes to 0. Okay, so if I make it 1, that means I have to move my graph over to the right. Okay. Um, well, let me just use this one. Let me just use this one right here. Oops. I'm going to move it over to the right. So it looks something like this. Okay. And now what happens now is if I implement this, as you can see here, I have a negative sign in front of the x, telling you and I that I have to implement a reflection about the y-axis. So when I do that, um, I'm just concerned about when I moved over to my um, when I moved over to my right by 1. Uh, just let me get this in here. Okay, and I'm going to actually rotate this about the vertical. So it looks like that. Okay, and but I'm gonna have to move this over. I'm gonna move this over by 1. I mean, it's at 1, but I just had to make sure it lines up with 1. Okay, so with this particular exercise problem, this is our basic function, f of x equals x cubed, and I had to move it over to the right by a unit of 1, and that's based on this value right here, right? Um, and when I say by this value right here, meaning that what would I have to make x be for this expression within the parenthesis to go to 0, and that's just 1. There's already a negative there, so it's going to be a negative plus a positive 1, that equals 0. So the graph shifts here. Okay. Then by there being a negative sign in front of the x, I have to reflect it about the y-axis, which flips it to look like this. So this would be my new f of x. F of x or y equals, I'm sorry, in this case it's going to be g of x. Sorry. G of x equals 1 minus x raised to the power cubed. Okay. Our last problem here is they want us to use the graph of a known basic function and utilize a combination of transformations to sketch the basic function. So if you look very carefully here with this particular function, okay, there's a few things going on. So typically start here, okay, and by this being to a 2, this typically tells you and I it's going to be a parabola. It's going to look something like this, okay. Now, by it having a negative 2. Now, if I make this x to be 2, that's 2 minus 2, that equals 0. But it's a positive 2, I just implemented, right? So I have to move this graph over to the right by 2 units. Okay? So from here, I'm going to move the graph over by 2. I'm right there. Okay? Now I've done that part. Now I have to flip it, or when I say flip it, meaning I have to implement a reflection because it is negative sign. So it's going to, this is my x-axis here. I'm going to reflect it about the x-axis, and it's going to look something like this. Okay? And I can get rid of this part right here. Okay? Now, I've done that part. Now, the next part is, the last part, is my vertical shift, and that's by a unit of 3 upward, since it's a positive. So now I'm just going to do this here and move this up 1, 2, 3. And that's my answer right there. And that's how the graph should look. And your function f of x equals negative x minus 2 squared plus 3. Okay. I hope this helps. Thank you very much. I appreciate you. If you have any questions, please let me know. Bye-bye.